So I'll make a note to look into that as well. Yeah, so that's parallel processing. We're running a bit low on time. Let me just demo the exercise and then we'll wrap up the day. So we're going to do some testing here of parallel processing to see if we can make our workspace more efficient. The starting workspace is here. We are reading some OpenStreetMap building data and performing some validation. It's checking the addresses first against a city address database. Then it's testing the geometry of the geometry validator. And then it's making sure they fall within a single zoning district. And then writing it out as validated buildings. So let's go ahead and open this workspace. This one is exercise, create a custom transformer for parallel processing. Going to turn on feature caching and run the workspace. Yeah, the drawback is that there's a lot of scenarios in which it doesn't give you a performance improvement because of those startup and shutdown costs I mentioned for each process. So you need to make sure basically that you have a small number of groups with a lot of processing that needs to happen in order to see benefits, or that other one where you're sending a lot of many requests off to some other system to do work where you just need to do it as fast as possible. So I think the common mistakes made by newbies is they just think they can turn any workspace into a parallel processing custom transformer and see benefits, and that is not the case. You have to kind of be in one of those two scenarios for it to work. To discover errors, there aren't really errors as much as there will be, you'll have to just benchmark. So if you suspect parallel processing could help, build a custom transformer into your workspace that uses it and do the timing that we were talking about earlier, measure your transformation time and see if it is improved with parallel processing. And then you can test with different numbers of groups if that's an option for you and see if it changes, for better or worse. And again, I would probably benchmark, run a few times, and take an average. Okay, so I've run this workspace. You can kind of take a look through and inspect if you'd like. The main thing we want to keep an eye on here is feature counts, because I guess that could be another area you want to make sure is you don't want to accidentally create parallel processing that increases your end result number of features, which is something that if you're not kind of paying attention, you could do. And it mostly has to do with which part of your workspace are you going to turn into a custom transformer. You have to be a bit careful there. Make sure that the output is still the same as what you started with. Yeah, so that's I guess the case there. If the results would be different. So the results, I guess, would be different in kind of two places. One of which is if you somehow have more features or less features at the end than you started with, which is sort of possible depending on what part of the workspace you turn into a custom transformer. And the other one would be if those groups actually are dependent on one another in some way, like if features in one group need to know something about features in another group, that could create problems. Now, normally you would probably have some sort of error, or you would try to make the custom transformer and realize, oh, I can't actually separate by groups this way because I need to know this value from another group or something, or I need to something like that. But I suppose there might be edge cases where the values of an attribute in one group are dependent on the values in another, and you might not notice if you turn it into parallel processing. So that's the main thing to think is make sure from design perspective, are my groups actually independent? So we can see we've got about 7,300 features at the end here. We want to make sure we keep that and we have the same amount when we do parallel processing. So we're going to make a custom transformer. The place that we're going to do it is around after the point on area overlayer. So we've got this one. At this point, we've got about 7,300 addresses. You'll notice we have a little bit more at the end there, but this is kind of a good way to look for it, is to make sure you're starting and ending with about the same amount of features. That means that might be an area you could do parallel processing. We also note at this point, if we expand the area, we do have a postcode attribute. And we could have a look at the values there and see that's actually a pretty good way to divide the data into groups. There's a pretty good number of them here. I don't actually remember off the top of my head of how many there are, but that might be a good way to divide them into groups. So let's turn a let's create a custom transformer that goes from the tester to the final junction here. The junction can be helpful there as well to make sure that you're just getting one output from your custom transformer, which is what we need in this case. So I'll select those, right click, create custom transformer. I'm going to call it building validator. And attribute references are going to be handled with published parameters. That looks good. I'll click OK. So now we've got this. This is a little messy. Let's make sure we move this out of the way so we can see it properly. Make sure everything else looks all right. That looks okay. So now we need to define the groups here. Make this a little bit better as well. One point, I guess, to note as well is that there was a reader inside that selection we just made. It is not included in the custom transformer. Instead, it's turned into an additional input port. This is for the zones, the zoning data. So let's keep that in mind because that will actually become a bit of an issue later. So we need to do some grouping. Let's do it based on postcode. Let's go back to the main workspace and we'll have a look at how to do that. If we inspect our data here and look at postcode, you'll see there's actually too many postcodes. But because these are sort of logically formed, we can take some subset. Let me see, where are my postcodes here? We can take some subset of these. Because you can see there's 6 alphanumeric characters. Let's just take the first 2, and that should give us a pretty good number of groups. So to do that, I'll add a substring extractor before the building validator. And I'm going to do it on postal code. And we're going to go from 0 to 2. So I guess actually we'll take the first 3. And so that'll give us a smaller number of groups we can use. Sorry, my lab is moving a little sluggishly today here. Question, geospatial, there might be a problem of moving data window. I suppose, yeah, that could maybe be an issue. I mean, you basically want to make sure that your groups are independent. That's as kind of as generic a way as you can say it. So you can see now we have a lot of groups that are in these subgroups. We'd have to count it up to see the unique values. It looks like maybe there's a couple dozen or less. So it might still be a bit high, but let's see. So we've got substring extractor has created that substring for us. If we look at the building validator, we can see currently it's not set up to use parallel processing. That's the default. So there isn't a way to set group by here. So what we have to do is go into our building validator, and then we'll turn on parallel processing. Let's set it to moderate for now. And then the group by is automatically set to a user parameter, which is what we want. So if we go back to main, now we can choose substring as our group by. So I'll choose that and click OK. I guess the instructions tell you to rename that, but that's fine, close enough. And then let's run it and turn off feature caching. I didn't take note of how long this took to run initially, which I probably should have done, but let's see how long this takes to run. Now, at this point, you could look into your task manager and you would see several FME.exe processes firing up, which indicates that parallel processing is being used. And this is running with as many different groups as there are in our source data. I don't actually know exactly how many that is, but now this is where once this is finished here, we can start to see some of the issues here. So that is the correct number. And then what we want to do is open this in Visual Preview. And we're going to filter. And now this is the kind of thing you would have to look at your data to actually know, I think. But we know in advance here that there's a little bit of an issue. Oh, right. I always forget to hit enable filter when I do filters. I was like, why didn't anything happen? There's this checkbox here, enable filter. And then we can see our results in the display view. And we can see that we actually have too many features here. There are 4,700 unzoned buildings in our results here. And that's a lot more than when we initially ran the workspace. So if you did the same filter on the initial data, there's 250 unzoned buildings before we added the custom transformer. So something has gone wrong here with how we've designed the custom transformer. The problem is the fact that this reader is not included in the custom transformer. Instead is used as an input. This isn't grouped by postcode. And so it's basically being read multiple times for each group. So the best way to fix this would actually be to move this inside the custom transformer, and we can do that using a feature reader. So feature readers are allowed in custom transformers, whereas readers are not. So what we can do is delete this reader, and then we can go into the building validator. Instead of using this input, we can delete that, and we use a creator and a feature reader. We'll point it to the map info tab dataset. Zones.tab. I'll click OK, and then I'll connect the, oh, excuse me. Oh, didn't like that. Why didn't I like that? Let me browse to that and make sure I didn't have a typo somewhere. Oh yeah, it's not in it. That's the incorrect thing. I need to fix that actually. It's under the zoning folder, then zones.tab. That is path is incorrect there. And then we've got our zones feature type. We can connect to the supplier. I'll save this. So now if we go back and rerun this workspace, we should see a correct output. Now, the question is, did that actually make a difference? We'd have to do some benchmarking to test. So probably what you should do when you start this exercise is run the workspace as is with feature caching off, take note of the time, and then you can run it again with feature caching off and take note of the time here to see if it actually made a difference. And in fact, I think I'll add an instruction to do that at the beginning next time, so it would save a little bit of time. So in total, this took 23.4 seconds. You'd have to go back and run the starting workspace to see if that is actually any faster. You can also experiment with different parallel processing levels to see if it is helpful. And you could also experiment with different numbers of groups to see if that improves the performance or not. And that's basically the result here is you can use parallel processing. You suspect you have benefits to be had from it, but you do need to do some benchmarking to determine the ideal setup in terms of number of groups and amount of parallel processing. And you need to be careful with your design to make sure you're getting the same number of features out as you put in and that your groups are independent.